Many thanks to PCB Way for sponsoring this video.
Good day everyone, and welcome back to the Explorer for another video. In today's video I'm going back to the very simple USB powered regen receiver. The basics of this receiver is the classic design by Charles Kitchen, N1 Tango Echo Victor, and all I did was just to adapt the receiver to work on a lower voltage. So just a quick idea for you is that I tried to design it to work with the 5 volts USB power that I'm getting from the laptop. The receiver right now is set up to work on 4.5 volts. I'm using a voltage regulator. I'm going to show you and talk a little bit more about that one in a little bit, but it allows me to use to power the receiver with any voltage from 5 volts up to 12 volts. So you can power it with USB, you can power it from 6 volts batteries, a 9 volt battery, a 12 volts battery, or a 12 volt power supply, and it will work just fine. So yeah, I've been playing with it for the past 5 days, trying to come up with the final schematic, trying to pick the value of the parts of the components in such way that it will perform the way I like it. You might have other preferences, so feel free to modify it if you feel like, but yeah, the way that it is right now, it's the most pleasing. I tried many modifications, which I had recommendations from people, but I've been talking to a couple of elderly friends from subscribers from YouTube that are 80 something years old, and they've been building this receiver, the classic version, quite a bit, and yeah, I got to learn from them. So yeah, we'll jump right quick here at the table and take a closer look. We're going to look at the final schematic and we'll talk a little bit more about it. But first we're going to have a quick demo that I recorded today, just because right now in the evening it's pretty hard with the LED lights. But of course we cannot continue without saying thank you to my friends at PCB Way for always supporting and sponsoring the DX Explorer channel. Remember, they have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more available for you. They also have a great store where you can order a lot of modules that might be useful for your project, and one of them we'll talk about just a little bit later in this video. Feel free to go check the project files that I'm posting on PCB Way, and you can order any of the PCB boards available over there, or if you don't feel like turning on the soldering iron, you can order the assembled version. As I'm always saying, PCB Way is the way.
Все самое интересное о Китае ждет вас в эфире международного...
Alright, so this is the final version of the receiver, of course, built on a breadboard. I'm going to build the final version once I get my PCB board over here to move all the components on the PCB board. But I wanted to talk really quick about the changes that I made, because I scrapped the entire idea that I started with, and that was to get rid of all the variable capacitors and only use diode tuning and stuff like that. But yeah, I changed my mind, and I will talk a little bit about that in just a second. On the screen you have right now the final schematic that I decided to use. Again, I'm powering the whole circuit with 4.5 volts, and we'll talk a little bit about that in a second. The reason why I decided to come back to the variable capacitors and remove completely the diode tuning, even the fine tuning, is just because I noticed how well it performs when I'm using variable capacitors, and why it's performing so poorly when I'm using diode tuning. And the reason for that is that basically when I'm using the diode tuning, I'm lowering the Q factor of the LC circuit, LC tank basically. And I already lowered that Q factor by using a coil with a smaller diameter and also smaller diameter wire, and by also adding the diode tuning, that lowered the Q factor even more, and the receiver just didn't sound it the way I like it, especially when it comes to CW, because I like that mellow sound of the CW, that it's a pleasure to listen to, not those chirpy, ugly sounds that I hear in many simple receivers. And it was the same with this one. It was just it just didn't want to sound the way I liked it. And if you remember, if you watched any of the videos about the Sputnik Regen receiver, probably you noticed there how nice the CW sounds, and I wanted the same from this one. I tried a bunch of versions and modifications that I found online, recommendations from people on how to do the regen control, about the biasing of the transistor, the coil. I built I don't know how many coils, trying different versions, PVC pipe, I tried toroid as well, and still so far the best version that I built, and it worked really nice, it was the one that it was sent by my friend Hendrik in Germany, and that version used the original size coil design by Charles Kitchen. Now over here in this receiver right now I'm using this coil. I'm not sure exactly about the final coil that I'm going to use. We're going to build one right now, and I'm going to test it after I finish this video. But I want to do this, I wanted to test this coil before making the video and show you, but I thought about filming the entire process of building the coil, just so you know, because it doesn't matter if you build a big one like the one that I'm going to build right now, or the smaller one, either of them that I'm going to end up using in the final design, you will still build it the same way, and you'll know how to build it, because this one I'm going to leave it for you to build it. If you order the assembled version of the receiver from PCB Way, they will not build the coil for you. You will have to build it on your own. And another thing that I wanted to talk about is the RF choke. In the schematic, it's just a simple 470 microhenry inductor. You can use that one, it will work without any problems. It's just that what I noticed, I winded my own RF choke. It's 2.5 millihenry, this one over here, on a ferrite toroid. Can't remember what material it is, but I think it's 43 material. You can calculate the number of turns using toroids.info if you want to wind your own RF choke. But when I change it to this one, I noticed a very slight improvement in the audio level on the output. Not too much, but you know, a little bit matters when it comes to very simple receivers. Anything else is very simple and very basic, so that's the way I decided to build it. I'm using 2 variable capacitors, one for the main tuning, one for the fine tuning. Now unfortunately I don't have fancy capacitors, I'm just using these very cheap variable capacitors. They have a name, but this plastic, I can't remember the way they're called, but you can find them everywhere, on eBay, on AliExpress. I don't know, I got them as a present from my friend Vlad, Yankee Oscar 5 Bravo Delta Lima. So yeah, this one is 60 picofarads maximum capacity. Minimum capacity is somewhere around 3 to 4 picofarads. This one is the same for fine tuning, but because for fine tuning I would need only 10-20 picofarads capacity, what I did, I basically put this one in series with another capacitor over here. I think it's 5 picofarads. And yeah, I left on the PCB board design. I'm nearly done with the PCB board as well. I left a space that you can solder a 5 picofarads capacitor or 10 picofarads, depending how fine you want the control and depending on the capacity of the variable capacitor that you have. But for example, you might have a 10 picofarads variable capacitor that you can use for fine tuning. So in that case, skip the 5 picofarads capacitor and simply solder a jumper wire over there. And yeah, I think that's it with the design. There's really nothing else special. Oh, the regen control, yeah, this is the way. I tried many versions, but this was the one that pleased me. It gave me good sound and good performance, so I decided to stick to this version. I wanted to actually use a variable capacitor as well for the regen control, because the control is much smoother. And you know, when you're using a potentiometer, you have this ugly hiss when you're turning the button. But a third variable capacitor was probably too much already, so I decided to stick to the potentiometer. But considering that I'm not going to play with it too much, I think I can handle with that ugly hiss. It's not that loud, but you can feel it when you play around with the regen control. But other than that, it works fine, it works fantastic, and this is exactly what I'm going to use for the final version of the Charles Kitchen regen receiver design that I'm going to build probably a little bit later, because I kind of built too many regen receivers by now. But that one I'm just going to keep the preamplifier part. Maybe I'm going to try to experiment with the JFET version. Not preamplifier, is basically an RF buffer to isolate the oscillator from the antenna. But I'm going to try to play with the JFET version, because I believe that one has lower noise, and if that one works well, then I'm just going to change that one. But the main circuit is going to be the same. The only thing that I'm going to change in that version is going to be the audio amplifier, because from here we'll probably play around with a preamp, maybe a CW filter, and then a final amplifier, and I'm going to build the whole thing only by using transistors. But I'll do that at some other point later on, not just yet. But yeah, it performs really nice. I like it. Now, of course, in the video that I showed you earlier with a little demo of this one, you have to realize that I haven't put this one in an enclosure, and once everything is enclosed, I don't have any touchy thingy. You know, when you're touching or you're getting closer to the variable capacitors, you're actually changing the frequency. That won't happen once everything is installed in a metallic enclosure, and I have a front panel from aluminum that will isolate my hand from the rest of the circuit. But the thing that I really liked, especially after removing the diode tuning, the fine tuning for using the diode, is that it became very stable in frequency. I left it today on probably it was some QSO in CW, and I just jumped in bed and I left it on. I was listening to see if it's changing frequency, you know, like moving up or down, and it was spot on. Like of course I still don't know CW, but I could hear the entire QSO properly. It didn't deviate from the frequency, and it sounds fantastic, so I'm really happy. Anyway, yeah, a lot of talk, but I am trying to explain the best I can, the reason why I'm doing certain things to the circuits, and the fact that I can power it from anything from 5 volts up to 12 volts, it's a plus. And now let's talk a little bit about that part. I'm using this particular module, and I really like it. You can adjust the output voltage that you like, the one over here. This is the input, so basically I'm powering with anything from 5 volts, a USB power supply from the laptop, or you can power it with 12 volts and it will work just fine. So yeah, it's great, I like it. So here's the way I'm building the coil. Basically, if you look on the screen, you'll see exactly the way I planned the coil in advance, just to fit my my PCB board later on when I'm going to put the coil on the PCB board. Probably I will make a hole in the PCB board that it will fit this diameter. And the way I'm building the coils, most of the time I'm building them the same way. So I have this diameter, I believe it's 20 millimeters or 22, I can't remember. Let me measure it really quick. Yeah, this one is 20 millimeters in diameter. So I'm cutting a piece of PVC pipe, a length that I believe that it will fit all the windings that I want to put on it, and then I cut another piece. This one is probably around 8 millimeters wide over here. It's the same diameter pipe, but then I cut a little bit out of it, so once I squeeze it, it will fit perfectly inside. And I'm going to leave probably like 3 millimeters outside, 3-4 millimeters, and then the rest of it will go inside, and I'm just gluing it with super glue inside the PVC pipe. And this way, by drilling a hole into the PCB board, when I'm going to put the coil over there, it will stay stuck in that hole and it will not move. And once I also solder the wires to the PCB board pretty tight, it will not move and it will stay there very well and very stable. And if you want, you can even add some super glue before putting it on the PCB board, so it will stay there very secure. And that's the way I like building all the RF coils that I'm building using the PVC pipe. Now I'm measuring the distance between here and here, and I'm drilling these holes. As you could see on the screen, I have 6 different holes. So this one on this side is for the RF coil, basically the coil, that side of the coil that goes to the receiver. Then over here in the front I have 2 other holes. This one is for the regen, the tickler winding, and this side over here is the one that will be on the left side. Is basically, where is it? Here is the winding that goes to the antenna side. And yeah, it will show you on the screen exactly which one is the beginning and the end of each winding, and the way they're supposed to be on the PCB board. So right now I'm going to start with the tickler winding, because it's the one that is the lowest, it's the closest to the PCB board, and this is the beginning. Basically, I'm going to introduce a wire through here, take it out from here, bring it back, and putting it down. So let me start doing it really quick just for you to see. Now, the way I calculated this inductor, I measured all the inductances of all 3 windings over here. So I know that the one for the tickler winding, it should be somewhere around 1.5 microhenry. We'll see. I calculated with the Coil 32 calculator, the app that you can find and download on your phone, but they also have the calculator available online, and you can calculate the number of turns depending on the inductance that you want. Now this is hard to do on camera, but I'll try to see if I can fit this wire. I forgot to tell you the diameter of the wire that I'm using. And to be honest, I don't even know, but I know that I used the calculator and I said that I'm going to use 0.5 millimeters wire. I believe this is 0.5, so I'm supposed to do 6 turns for the tickler winding. So I'm going to do 6 turns. It's pretty hard to do it on the camera. Let me zoom out a little bit. One, 2, 3, 4, 5, and 6. So right now I'm going to cut the wire. I'll have to drill another hole for the end. Now you have to excuse the way I'm filming, but it's hard to concentrate on what I'm doing and also to concentrate on what I have on the screen. So this hole that I'm drilling right now, it's going to be right here at the end, and it will be on top of that hole where I have to take the wire out. And basically I'm doing the same for all 3 windings. Now this is the hard part, because this is wire that I'm using from a transformer, and because it was heat up in the past in the oven when they added the varnish, the one that you heat up in the oven so the transformer will stay still. The wire becomes very easy to break if you move it too many times. Now I have to manage to bring it out, and we did it. So the first winding is done. Put the wires really close together. I'm going to arrange it a little bit later once I'm done with the entire coil, but this is the way it looks, and it's really nice and it's very secure, and you don't have too many wires wandering around, and it's really nice when you want to build one of these kind of inductors and place it on the PCB board, because it's very easy to plan in advance where you're going to have those holes, and the wires will go straight into those holes. So I really like this this way of building building coils. Of course, inside is not always that pretty, but who looks inside? So I'm going to continue with the rest of the windings, and I'll be back to show you the final coil. Alright, I'm done with the coil. Well, it's upside down. It will be like this. Definitely I'm going to cut the extra part that it's over here. I don't need it to be that high. but I usually leave it a little bit higher and cut the extra part rather than building the coil and then realize that I don't have enough space on the PCB on the PVC pipe. So yeah, I try to make the turns as close as possible to each other and as tight as possible, and usually once I finish everything I spray them with a thin layer of varnish just to keep them together. Maybe 1-2 layers enough to hold them together really well. So yeah, just in case you will build this receiver, so looking from up, we have here the antenna coil, because right now everything is upside down. Once we're going to put it like this, it will be the right place. So this is the antenna side, this is the beginning of the coil, and this is the end of the coil. Now if we move to the next one, this is the first coil over here, and this is the thickler winding. This is the beginning, this is the end. And over here we move again, this is the beginning and this is the end. It's very, very easy, and you won't mistake when you're building the coil. So yeah, now all I have to do is to scrap the insulation from the wires, put it on the receiver and test it to see if it works. We'll see. The reason why I would like to use this one, I cannot build another one if this one doesn't work. I run out of wire. It turns out the thickness of the wire is 0.6 millimeters, not 0.5 like the way I used when I made my calculations. So probably the inductances will not be exactly like the tiny coil over here, but we'll see. If it works, then it's fantastic. If it doesn't work, well, I'll go back to this one because I have enough wire to wind many of these coils, thanks to my friend Vlad, Yankee Oscar 5 Bravo Delta Lima, for sending me the copper wire. So yeah, the reason why I would like to use the thicker one is because thicker wire and also a larger diameter of the PVC pipe will also increase the Q factor of the inductor of the coil, basically the RF coil, and obviously it will increase the Q factor of the entire LC tank that we're using into this receiver. Also using thicker wire, I realized so far in the past 3-4 years that I've been playing around building circuits, and especially the ones that are using coils, inductors, or whatever we call them. When I'm using thicker wire, it's less sensitive to temperature. So basically, how can I explain it? The temperature changes won't affect the inductance so much as it would when I'm using, when I'm using thin wire. I'm not sure what's happening with the wiring. Maybe it's with the wire, maybe it's squeezing when it's really cold, and it's dilating when it's warmer. But it will probably change the inductance just a little bit, not too much, but once you're listening to CW signals, probably you might feel the difference. It's the same with the capacitors, and also when the wire is very thick, then it's very tight. The turns are very tight. It's very well built mechanically, so it will not move so much, and once you fix the turns with a layer of varnish, it will stay very solid and you won't have any problems. So yeah, right now I'm just going to test it. I'm not going to waste any more of your time because it's already a long video, but if it works, then that's the one that I'm going to use in the final version of the receiver. and that is the one that you will going to have to build. Any of them that will be in the instructions, basically in the download folder. When you will have the schematic and everything, you'll have all the details to build the coil as well. So that's it. I'm done with this video. I don't want to waste any more of your time. So thanks so much for watching. I hope you liked the today video, and I hope you liked the receiver as well. I cannot wait to finally finish the designing the PCB board. I'll make it available for you very soon. I'll put the link in the video description of this video as soon as I'm done with it. Probably tomorrow, the day after tomorrow, one of these days, I will post the link. So please come back to the video and check the link in the video description. So yeah, I'm happy with the way it works, the way it performs. I cannot wait to have it finished here on the side, on top of my power supply, and while I'm working on the computer I can listen to some radio waves. Well, I cannot really listen to the radio waves, more to the to the decoded radio waves. Anyways, thanks so much for watching. I'll see you probably tomorrow in another video. Until then, 73 from Yankee Oscar 6 Delta X-Ray Echo.